Today's presentation is going to be regarding the protection of storage, and most particularly, it's going to be kind of getting through the requirements in NFPA 13 that get you to that protection of storage. So really, it's similar to the occupancy approach. There's similar questions that you need to ask regarding kind of what's being stored and kind of the whole characteristics of the building that you're looking at in order to properly design and choose. When we get to we'll talk a lot about this quick reference guide, but when you're actually choosing the appropriate sprinkler for protection of this particular space. So in this particular case here, what we're going to be looking at is just kind of getting through what can be a fairly confusing, if you will, series of questions that we need to ask and get answers to in order to find out how we're going to protect storage. So really what it comes down to is, where do we start? When I have a warehouse going in, or I'm going to do an inspection on a warehouse, for example, on an existing system, where do I begin? What's the first question, or what is the order of questions that really I should be looking at? Because when it comes right down to it, NFPA 13, for example, just to start with, as far as the design is concerned, it has a series of different chapters that deal with the protection of storage, that deal with different ways that sprinkler systems are designed to protect storage. There's chapter 12 with the general requirements, and then chapter 13 deals with something called miscellaneous or low piled storage, and then we get into the piled storage or rack storage, and then special storage arrangements. And it can be very confusing. It can be very kind of intimidating until you begin to realize that it's really a series of a couple of questions, or really four questions or so in a row that kind of get you right to where you need to be. I mean, all of these things don't always come into play with every storage arrangement. So once you start to kind of hone in on those particular requirements or answer these particular questions, you'll begin to see that, oh, all right, the solution kind of becomes apparent, what we're trying to do. So here are the questions that we want you to be asking in order to kind of navigate your way into the right area for the specific requirement. So to start with, then, we need to ask, what is the commodity? Okay, what is the commodity classification? When we were talking about occupancy classification design, we said it was either light hazard or ordinary hazard group 1, or extra hazard group 1 or group 2. So we had a way of describing what the fuel package was in that room. And remember, we talked a little bit about, okay, how much water is it going to take to control a fire in those occupancies? Well, it's similar to this particular arrangement, to storage as well. What is the commodity classification? So we'll talk a little bit about commodity classifications here in a moment. But mostly it's what's burning. All right, what is it that's going to burn in this particular arrangement, in the storage warehouse or in the storage area? Now, a subset of that is also, how is it packaged? Okay, because if we take something that's non-combustible, we take a desk, a steel desk or something like that, or a steel washing machine or something along those lines, that's non-combustible. That's not going to burn very well at all. But if we put it in a multi-layer cardboard box, it might have something else. It might have a different characteristic. Okay, if we wrap it in plastic, it might have a different characteristic. So we kind of need to be careful with that. So we need to ask a kind of a sub-question of how is it packaged, because that has an impact on the overall classification. Then how is the commodity being stored? Is it being stored in a pile? Is it being stored on racks? that has an impact on the design itself as well. How high is the storage? We get into when we start to look at the specific chapters that deal with storage protection, we're going to see that we start to divide this off into, all right, is it more than 12 feet? Well, that's this type of storage. Is it less than 12 feet? Well, then that's this type of storage. Is it on racks, and how high are those racks? Well, that's going to have an impact on your overall sprinkler system design. It may not change the commodity classification, but it's certainly going to have an impact on what sprinklers you can use and maybe what kind of arrangement you can have those sprinklers in. After that, what type of sprinkler are we trying to use? We gave you the quick reference guide that we'll go through here when we get to that point, but what type of sprinkler are we trying to use? What sprinkler is appropriate for the protection in that particular space? And then, is it a special commodity? And the subset of this is it a special arrangement? Okay, we've got, what we have found out anyway over time is that the storage industry is a fairly dynamic industry when it comes to how they store materials, how they move materials around a warehouse, how they access that material, and again, how that whole structure that they're building around accessing and moving material around has an impact on the sprinkler system's ability to control a fire, right? If we have racks that are stored, that are, single row racks that are 8 foot aisles, boy, that's one way to, one issue to deal with. But you start to bring those racks together, and instead of having 8 foot or 4 foot aisles, you're putting them together into 2 foot aisles with a machinery, with a picker, automated picker that goes down that aisle and picks in. Now you've got a density much higher than that. You've got a density of materials that are going to burn and create a challenge for our sprinkler system, far greater than you have when you had a lot more space between your storage racks. So it's not just a matter of the commodity, is it a special commodity, but is it a special arrangement in the way it's being stored? So when it comes to a commodity classification, similar to, again, the five types of occupancy hazards, when we had light hazard, ordinary group 1 and 2, extra hazard group 1 and 2, you have 7 groups or 7 commodity classifications. And these commodity classifications then describe or are defined by the basically by the ability of the commodity to burn. All right. So class 1 being the least combustible, all the way up to group A plastics, which are the biggest challenge for a sprinkler system to control. So let's take a look at these commodities to start off with, because we're not only going to, again, remember, it's not only about the commodity, it's how the commodity is packaged. All right, and then we're also going to find out that there are other things like how the commodity, what kind of pallets the commodity might actually be stored on that have an impact on this classification. So to start with, let's take a look at some of these commodity variables. Will the product burn or not? Will the packaging, does it help or hinder fire growth? Storage method, is it on pallets, solid piled, single, double, or multiple row racks, movable racks, portable racks, all kinds of other arrangements that we might have. How is that? These are the variables as we go through each of the, as we go through each of the chapters. What's their rate? What is the rate of heat release? How much heat will this thing put off? How rapidly will it burn? Not just will it burn or not, but how rapidly will it? And then if we've got, do we have data to prove that, to back that up? A lot of this information that we have on storage was basically done by a collection of burning material, and then kind of comparing the material that we burned to another piece of material we were trying to classify. So just because as we come up with all these commodities and we start showing you examples of these commodities in each of these classes, doesn't mean we were done, doesn't mean that actual burning tests were done on those. We did a couple of burn tests and then a couple of burn tests were done back in the 70s, 80s, and then we started to compare that commodity to what was burned and trying to say, all right, well, this will fall into this category. But as you can see, as you'll see as you go through, the family of categories is, the commodities in each of these families is pretty closely linked together. So let's take a look at a commodity, a class 1 commodity. Let's see what the standard says about a class 1 commodity. To start with, it is a non-combustible product that meets one of the following criteria. It's either placed directly on a wooden pallet, all right, so it's a solid commodity, non-combustible, on a wooden pallet, or it may be placed in a single layer corrugated box with or without dividers and with or without pallets. Okay, so we could have a non-combustible material that's placed in a cardboard box. Now the cardboard box is combustible, it's combustible packaging, but it's only a single layer in this case. Or it could be shrink wrapped or paper wrapped with or without pallets. Okay, so now we also can see that we can just put this without a box at all. We can shrink wrap it around, and non-combustible commodity, so we can wrap it and package it that way, and it doesn't have an impact. Because remember, the base commodity is non-combustible. Here's an example, all right? Just non-combustible product placed on a pallet. Now, the way we got to this first commodity, class 1 commodity, thank you, is that this is the class 1 test commodity. We had a test commodity. We had glass jars, non-combustible, in compartmented cardboard cartons, single layer glass jars within that commodity. Burn that commodity, determine its heat release rate, and use that as the test commodity to compare these other commodities to. So it's non-combustible in a single corrugated box. So by definition, that was going to be the single layer corrugated box was going to be the biggest challenge. And all of these placed on, when they were tested, placed on wood pallets, solid wood pallets. All right, when they're being tested, yeah.
So in your industry, because this is something that we're just starting to grasp now. We get the BTU per pound, we get that.
Right.
But what we don't get as a fire service for fire suppression is heat release rate.
Mm-hmm.
So in your industry, I'm not saying you're not concerned with BTU per pound, but it's heat release rate is your criteria.
Right. What we have what we call in the sprinkler industry typically is we convert this heat release rate. We look at how fast it burns, how much heat's coming off, and then we determine basically, through other through other tests, what we call its required delivered density. In other words, this commodity is going to burn at such a rate, it's going to require this much water to spray around it in order to control the fire. So we kind of live and die on required delivered density, because then we're going to build out our systems, our sprinkler systems, and we're going to select sprinklers, and we're going to select piping, and we're going to select water, whether or not we need a pump or anything else on this system to deliver an actual delivered density, which is the water that comes out of the sprinkler minus the water that gets carried away by the heat, and it actually gets to the base of the fire. Okay, so what we got to do is create an actual delivered density that can get through the required delivered density, deliver water down to the base of the fire. So yeah, it becomes a challenge, but that's pretty much the balancing act that we're looking for.
The next, you said solid pallets. You're not talking about a solid deck, but just solid wood.
We're just talking about a solid wood pallet. I mean, just the standard old-fashioned wood pallets. All right, no lightweight construction, no plastic construction in this one at all. The test commodities were tested on solid wood pallets. Now that becomes important as we get a little bit further on into the commodity classifications. Okay, so the class 2 commodity now, we're going up again, up a level, is once again, it's a non-combustible product. But in this case, it's no longer just in a cardboard carton, it's in slatted wood crates, solid wood boxes, or multiple layered corrugated cartons or equivalent combustible packaging, with or without pallets. Okay, may have pallet, it might not have pallet. So in this case here, you can see same product, just in a different packaging. What changed? The way we packaged it. So the test commodity, I should have just gone right to the test commodity on this one, in this case is a non-combustible product with multiple or tri-wall corrugated cartons, wood pallet. Okay, so once again, on a wood pallet, this is what we burned, non-combustible with multiple layers. The class 3 commodity now becomes a wood product of paper, natural fiber, or group C plastics. Now we'll get to the group C plastics here in a moment. But wood, paper, natural fiber, with or without cartons, boxes or crates, with or without pallets. So this is a combustible commodity. So we've now gone to class 3, now we're introducing it as a combustible commodity. Now, when we get into the plastic and we start to talk about how group C plastics or group A or B plastics come into play, this also recognizes that there can be, in this particular commodity, a limited amount of group A or B plastics. So remember that group A plastics are the biggest challenge. They're the most combustible. So it kind of goes in reverse. We're going 1, 2, 3, 4, and then CBA is our reverse logic on how the combustibility of the plastic. So group C plastics equal class 3 commodity. Group A or B can be brought in, except that we only a slight amount. All right, so here we go. That's a little bit better. Class 3 commodity, it's combustible. And it's just on its face, it's just desks stored, combustible wood desks stored on top of each other, no pallets involved, but no plastics involved either. The test commodity here was paper cups in compartmented cardboard cartons on wood pallets. So paper cups in a compartment in a single cardboard carton, single wall cardboard carton. A class 4 commodity needs to meet these criteria here. So again, it's combustible. Now it can be group B plastics. All group B plastics are considered class 4 commodities. You can have what's called free-flowing group A plastics. Now, group A plastics basically are, well, when it comes to free-flowing, it's if the cardboard box opens or if the container opens, will this material, like packing peanuts or something like that, will it flow out into the space and cover and fill kind of the void spaces around the box, around the pile of storage? If that's true, then you can classify that as a class 4 commodity. If not, then we have to go and protect it as a group A plastic. Once again, here the class 4 commodity is a combustible commodity that also contains 5 to 15% by weight or 5 to 25% by volume group A plastics. So again, you're starting to see that we're really now shrinking this down from that group of 7, we're down to probably 5 now commodity classifications, really, when it comes to how we're designing our sprinkler protection. The remaining material here can be group class 1, 2, or 3 up to class B or group B plastic. So class 4 commodities, basically combustible commodity, but it also can have a number of other plastics involved in it. What we did to test this then was Paper and plastic cups together. All right, 5 to 15% by weight, 5 to 25% by volume. So you can see that they're interspersed here with the paper cups in single corrugated cartons on a box, on a pallet. So when we take a look at these, then when we take a look at kind of how do we determine that language before by the class 3 and 4 can contain a limited amount of group A plastics, so it's cartoned or exposed for B. In this particular case here, what we have is a table or a figure in NFPA 13 that shows you what we were talking about before with commodities containing a mixture of expanded and unexpanded group A plastics. So what we have here is a class 3 commodity, 5 and 5. 5% percentage by weight, 5% by volume. Right here. Okay, it would be a class 3 commodity. This is group A plastics in a class 3 commodity, 5 and 5. If you're in a class 4 commodity, all right, we set up to 15% by volume, or excuse me, by weight, 5 to 15, or 5 to 25 by volume. But you can see that that this figure is saying that the further you go up by volume, the less amount you can have by weight. All right, this is where we're going with this. We don't want to have 15 and 25. Okay, that would be a lot. All right, the same thing applies in figure 56333, exposed commodities containing mixture of expanded. Once again, in this case here, we're saying 5 and 5 or 15 and 5 by volume. Okay, so the plastic commodities then come into, and again, this isn't a science lesson, so just kind of, this is the list of what we see in Group C plastics. Melamine formaldehyde, anybody ever heard of that? PVC, I guess, is the one that most people are going to be able to say, oh yeah, okay, I know what PVC is. I've seen the piping. All right, polyvinyl fluoride, but basically these are considered to be Class C commodities. Group B, cellulose, acetate cellulose, cellulose materials, nylon, natural rubber, not expanded, silicone rubber. These are part of the group that are Group B plastics. And we get into Group A plastics, we see that, let's see, natural rubber expanded, polystyrene, margarine is considered that's really not something you see very often. Margarine's considered a Group A plastic. I like that. Polyurethane, PVC, polyvinyl chlorine, highly plasticized, candles, mattresses, foam, milk containers, things like that. The unexpanded Group A plastic commodity, unexpanded here, polystyrene cups in compartmented cardboard cartons. So it's important to note that these are this is unexpanded plastic. Okay, plastics in this case are expanded or unexpanded, and unexpanded is the polystyrene cup, the little red cup. Red Solo cups, you've heard the song. All right, that would be, yeah, what you got one right there. Okay, because there's not been any air infused into it. I mean, that's typically when you get into the expanded is polystyrene trays that are exposed. In this particular case, here's our test commodity. But those polystyrene trays, any kind of that plastic tray that kind of feels kind of spongy, that is an expanded plastic, and because it's got air in it, infused in it, these are going to burn. These are probably the biggest commodity challenge. In fact, they are the biggest commodity challenge as far as protection is concerned, because the plastic burns really, really well, and it's infused with air in it, so that it's got a natural supply. So we need to wind up with some pretty serious fires here and a big challenge for our sprinkler system. So, bringing it all back around together here, Class 1 and Class 2 are non-combustible commodities. Class 3 and Class 4 are combustible commodities, which include Group C plastics and Group B plastics. So what we've done is we took that list of 7 and we brought it down into 4 plus Group A plastics. The one thing that's not in here is the standalone Group A plastics. So remember that each one of these can have a certain amount of Group A plastics in it without being considered wholly Group A plastic to be protected. So these are the 4 basics, and then you've got the Group A plastic, the 5th one on the outside. Do we ever have just a monolithic warehouse of just all the same stuff? Rarely. Rarely would you find anything like that. So what do we do when it comes to mixed commodities? How do we look at this warehouse full of these different types of commodities and protect it?
Most stringent.
The most restrictive. It certainly is a way we can do it. Okay, that's one way to look at these mixed commodities. All right, is to say, look, we're just going to protect for Group A plastic and be done. That's possible. Why wouldn't we want to do that?
Cost, if you're the owner.
Cost. If I'm the owner, definitely it's always going to be about, it's never about money until it's about money, it's always about money. Okay? But that's the case. All right? It's always going to be cost driven. What do I have to do? So if it's purely mixed commodities and you can't segregate them anywhere, you can't separate anything anywhere, then you know what? You're going to be protecting it based on the most challenging commodity you have in the location. All right? So option 1, protect the entire building for the highest or most demanding commodity. Gold star. You got that one right. Or option 2, you can confine the higher hazard material to a designated area and protect just that. Now, that's going to be one thing if we've got like a logistics warehouse and we know that we're always going to be going and getting these materials from this spot. But you go back to Lowe's or Home Depot or something like that, no. This stuff is all over the place. Option 3, then, to randomly space a few pallet loads at the higher commodity without changing the classification. So what it's basically saying is, if you do the randomly spaced option, then up to 10 pallet loads of the higher commodity in any 40,000 square foot area are allowed in most circumstances, randomly spaced and no adjacent pallet loads. Now, that's all well and good on opening day, but how are we going to manage that going forward? Okay, especially as things start to, we got a new commodity in. You know, we just got this brand new product we're moving. Oh, it's Group A plastic. Well, all right, let's put it over there. No, you can't. It absolutely has to be maintained. It becomes a big challenge for inspections going forward. You know, for the fire inspection division coming forward. It becomes a big challenge to make sure they've maintained that kind of separation. Yeah,
It's almost impossible to regulate.
Sure.
And impossible to enforce, other than the fact that once you have find 2 that are next to each other, boom, you've got to go back to do this thing.
Sure.
So all of us say that's when you're talking money again.
Right.
And so the thing to do would be sell it up front. That
Right.
Since you got an $8 an hour guy run that forklift, he's going to put it wherever you can find a spot. So therefore, you can't set.
And keep in mind what a big impact that has on sprinkler system design. We're jumping from what could be a class 4 commodity with a specific, with a specific design density design arrangement it has, to a Group A plastic, which is considerably more difficult to protect against and requires considerably more water. So it would really be advantageous to absolutely for the owner to make sure that happens. They never it's never segregated, or it's never, you know, we
You
obey
segregate
these
your
particular
Class A
rules.
to one section.
So clearly it's going to be advantageous for them to do that, which is why you see a lot of people just go, yeah, just group A plastic. Go ahead. It allows the most flexibility because there's another idea, keep in mind these mixed commodities and the challenge with this. We're also going to, last word, the number of pallets of class group A can be reduced to 5. All right, when fire protection system is designed for class 1 or 2. All right. So that's the impact of Group A plastics on others. All right, that's that mixed commodity requirement or the mixed commodity challenge. Now we got to take a look at the pallets. What is it stored on? Because remember, when we first mentioned the commodity classification, all of those test commodities were what? On wood pallets. All right? Because back when these things were tested, back when we were burning these things, there weren't any plastic pallets. Okay? So in this particular case, the effect of the plastic pallet now is going to can have a significant impact on the overall the overall protection scheme here of the sprinkler system, the overall design. So here's the impact. The commodity classification, as we said before, assumes wooden or metal pallets. That's what it assumes, that's what it was based on. Plastic pallets, no, they're not just permitted, they're used. I mean, that's a fact of life. As long as we obey these particular, we gotta follow these particular rules here. If I have unreinforced plastic pallets, the classification goes up 1 class. All right? But it's got to have a permanent marking that it is an unreinforced plastic pallet. If it's a reinforced plastic pallet, then you go up 2 classes. All right? Unreinforced goes up 1 because it'll fall apart during a fire. This will lose its structural stability in a fire. Reinforced goes up 2 classes, reinforced plastic pallets, because these pallets will not lose their structural stability in a fire, or they will resist it much longer, basically holding the pile up, all right, keeping stability in the pile, which allows it to burn easier than if the pile falls in on itself. So in this case here, if I have a class 2 commodity, defined having my pallet on the class 2 commodity, my wood pallet, I have to protect it as a class 4 commodity if I'm going to be using reinforced plastic pallets. Now, how do we know this? How do we know whether or not we're going to be using plastic pallets in the logistics industry? How are we going to find that out? It's guesswork to start. Okay, once again, what do you design for? Do you design knowing that it's a class 2 commodity, assuming that that eventually you're going to have plastic pallets in there? And protect it like a class 4? I don't know. You're going to have to be a lot of discussion between the owner, the designer, contractor going in, everything, the AHJ. How are you going to manage this? A lot of our stuff now is being transported on plastic pallets. Wood pallets are still out there, still see a lot of them. But plastic pallets are a fact of life. So what do we do now? Anyway, the important point I was making there, the important point we're making there is that it's not just the commodity or the packaging that impacts the commodity classification. It's the whole, you have to take a holistic view of everything that's going on here, all right, with result that comes into contact with that commodity. So what comes into contact with the commodity? The box does, okay, that has an impact. and the pallets do. That has an impact. You take a class 2, it goes up to a class 4. Okay, now, the example of reinforced plastic pallets here, basically, what it says, what the standard used to say is that it used to say that you had to have that reinforced plastic, you had to have that particular item on a reinforced plastic pallet. That's old school. What we found was you couldn't figure that out. So now, if you go back to this here, it's the unreinforced plastic pallets. We're going to assume a reinforced plastic pallet. You're going to have to show me that it's unreinforced. Used to be, in the old stand, in a couple of editions ago, you had to show that it was reinforced. No. We're going the other way now. That it actually must have a permanent showing that it is unreinforced in order to get away with just the single increase in commodity classification. Okay. So again, one of finally here, the effect of the plastic pallet, no increase for Group A plastics on plastic pallets. That's because there's nowhere to go. Okay, Group A plastic that's it. You're already there. Pallets are assumed to be reinforced unless permanently marked by or certified by the manufacturer. No increase is required where the sprinkler system uses ceiling-only sprinklers and uses a minimum K factor of 16.8. That's important, okay? That you can no increase if you're using 16.8 K factor or greater. No increase required where non-wood pallets have been demonstrated the hazard like or less than or equal to wood and are listed as such. So if we've come up with some new pallet product that burns like wood, then we don't have to. We wouldn't have to increase there, but there needs to be documentation. So again, Group A plastic, don't go anywhere from there. Pallets have to be permanently marked as unreinforced. Pallets are assumed to be reinforced unless they're permanently marked the other way. No increase if we're using case 16.8 or better, and then if we have some sort of new pallet product, it can be recognized. Now, once again, the effect of packaging. Now, in NFPA 13, there are in the annex of NFPA 13, there are a number of tables that give you examples of what each of these commodities might be, of what each of these commodities might be as far as their groupings, but also as far as what each material might be as far as its commodity. So they kind of break it out both ways. And one of the items that's particularly interesting is food-based products, and how they're stored. So this is all frozen food right here. All three of these are frozen food products. This one is simply stored in a cardboard box, cardboard container, cardboard wrapping around it. That's it. Class 1 commodity. Now you take the Gorton's fish sticks here and you put it in a plastic box, if you will, or in a plastic. What's the term I'm looking for?
Cardboard bag.
Yeah, it's plastic wrapped box. It's then same stuff, basically frozen food. It's a class 2. It's that wax coated box thing. That's what I'm looking for. All right, that's the term. It's kind of a wax coated box. That's a class 2. And you take frozen food, you put it on a polystyrene tray. It's class 3. Right? Put it on a plastic, not a polystyrene, on a plastic tray. You put it on a regular straight plastic tray, that's class 3. So same stuff, same basic material. We haven't even talked about the pallet or anything else that it's put on. It's going to have a difference depending on how it's packaged.
The fish sticks inside had plastic too.
Pardon?
The fish sticks
The
inside
fish
they
sticks.
had plastic. I'm saying carton outside.
Oh,
inside.
yeah, no, in this particular case, that would just be, we're looking at the wax coating of the box itself. No, the plastic on the inside probably isn't gonna have that impact. when you look at the annex, it's wax coated boxed, the box container that you're looking at there. All right. So that's the commodity. All right. That is the commodity and what it's stored in and what it's stored on. Now we need to look at how it's being stored. Okay, so we've got this box, we've got this box, it's placed on a pallet. We know that. We know the commodity classification. We've given it a commodity classification based on the definitions and the terms that we've just followed through. Now, how is it being stored? And by that, what's the configuration of the storage? Is it palletized, or are we just storing it on top of one another? Is it just boxed solid pile? Is it in a bin box? Have we placed it on shelves? That burns a little bit differently. What about back-to-back shelving? Or is it in rack storage? And then in rack storage is a single, double, or multiple rows. So here's 6 different items that we now have to look at after. This is after we've asked the question of what the commodity is. How is it now being stored? So if it's palletized storage, I mean, you basically see that with this particular pallet load here, all of these things are solid pile, basically, or solid pallet loads on a pallet. The pallets are all going in one direction here because that's the easiest way to access them. You have to access them that way with the fork truck, okay? But this is pretty solid pile, palletized. It's palletized, but it's in a real solid pile here. And the reason that that we look at it that way is because we don't have much space in between here. And so if we started a fire out here on this material, it would take a really long time for it to get going. Because all it would be burning would be what's on the surface. Okay, very difficult to get it in here. Once it gets in there, it's pretty stubborn, but there's not a lot of oxygen drawing it or allowing it to get in there. Okay, so that's one way of looking at it. That's called what we call a closed array storage arrangement. In other words, the closed array is there's not a lot of air that moves around the commodity. Okay? Solid pile storage, again, this sort of looks like the same thing with the pallet load, but these are all just crates, and again, very closed off in the array of the pile, very tight together, not a lot of oxygen, air being able to move around there. Is it on shelves? So now we may have less density in this space. I mean, take a look at it, it's kind of all spread out a bit. But now you have a little bit more air between these, but you have a lot of segregation in the shelf itself. Okay? So again, this is another way of looking at how we're storing it. We have a commodity in a box, class 1, class 2, class 3 commodity, whatever it is, but we're storing it on shelves now. Then we arrive at this arrangement called back-to-back shelving. Now, when it comes to shelf storage is limited in its depth. That you can have a single shelf unit coming out. Basically, it's 30 inches in depth going one way. But now all of a sudden we're confronted with this back-to-back shelf arrangement. Well, what happens if I have a back-to-back shelf arrangement? We didn't have anything like that up until about, the 2010 edition of NFPA 13. But if I have back-to-back shelving, so let's just say we start off with a shelf that looks like this. All right? There's my shelf, and I put my commodity on it. And that's a fuel load. All right, that's one way of looking at it. But what happens if I have this? At a greater fuel load, you think? Sure it is. What's this made of? Does this separate the two? Or is this a perforated you know, pegboard, something or other, or just, you know, maybe a screening that keeps this stuff from coming over on this side, and that just a little barrier. Or maybe it's just open and there's a little barrier right here that keeps the boxes from going over. Is that a bigger problem now? Absolutely. You've got all kinds of air moving through this particular that you didn't have as a single. All right? Think about grocery stores to begin with, to start, okay? Classic examples of back-to-back shelf storage. Aisle 3 and aisle 4 are the opposite sides of back-to-back shelf storage. All right? 2 solid perforated shelves up to 30 inches in depth each. So what we basically have here is this is the limitations placed on back-to-back shelf storage. Total depth of 60 inches. Separated by longitudinal vertical barrier, such as plywood or particle board. You can have a small diameter penetrations in it, but no longitudinal flue space. All right, we have no air. In other words, we don't have anything here, in between here. No longitudinal flue space and a maximum storage height of 15 feet. I think I even have a better diagram than that. Maximum of 30 inches, maximum of 60 inches, maximum of 15 feet. Okay? Now, in the case of a grocery store, that's not the best example of this type of storage arrangement, because 15 feet is too high for me to reach. It's too high for you to reach. Typically in a grocery store, you're going to have them what? Around, I don't know, 6 feet? 6 feet high, maybe 8 feet to just keep. So if you're under 12 feet, you're not even in the storage commodity. You're not even considering storage commodities, right? Unless it's low piled storage and low density, which we'll get to in chapter 13 here momentarily. Now let's take a look now at when it comes to piled storage, let's take a look at that closed array or open array, because you kind of have a combination of them right here, where you've got a closed array here and an open. It's more open here, between here and here. So when it comes to the array, sometimes when we're defining our protection scheme, we need to know how open that pile is going to be. Is it going to be really tightly packed pile, or is it going to be an open pile? Because that does have an impact when we get into chapter 14 or chapter 16 in the storage in the requirements for the protection arrangement. It does have an impact on the overall design densities for protection of that storage. Now, so does encapsulation. The designer will run into situations where they need to determine whether or not the commodity is going to be encapsulated or not. All right? Now, if I've got encapsulation involves wrapping that entire pallet load up and on 5 of the 6 sides, basically, top and bottom, all the way around in place.
Shrink wrap?
Shrink wrapped, yeah, shrink wrapped, absolutely. That's the encapsulation. Now, if I have just plastic wrapping around one box and then I'm placing that box on top of others and they're all individually shrink wrapped, that's not considered encapsulation. Encapsulation is around the entire load, the entire pallet load that's going onto that particular, is going into this shelf. Now, why is encapsulation such a challenge or such a problem or a concern for fire sprinkler systems design?
No water entry.
Pardon me?
No water entry.
No water penetration, right.
The rain
Okay,
will go over
yeah.
it.
This stuff will burn inside, the plastic things will burn inside, and it won't, the water can't penetrate in. So that's going to have an impact on our design. Not so much individually wrapped, but when the pallet load is wrapped, you can get a decent burn going in there before it breaks out. You can't get the water inside. So what do? We say you can't store it that way. So what do? We increase the amount of water that's coming out. All right. You have specific adjustments that you make when you have encapsulated, in certain cases, when we have encapsulated storage.
Now that would be through a combination of what, like ESFR heads or in-rack storage or rack.
It all depends. In this particular case here, it could be the use of in-racks. Okay. In this particular case here, if these are, I said individually, but these are actually wrapped and encapsulated all around. Well, you're not going to be using ESFRs or in-racks to protect this.
No.
So, but you are going to have a different flow requirement. You're going to have a different density requirement coming out of your ceiling sprinkler. So it may require an ESFR sprinkler, or it may require one of the other ones we'll talk about. All right, pile stability. Here's an example of a fire test that was done, and the piles began to fall over on themselves. All right? If we've got stable piles, those are a higher challenge. All right? Because they stay up. Whether they're using wood pallets or reinforced plastic pallets, they stay up, they stay vertical, which means that the air stays around all of the pallets, the stored commodity, and we can have the fire will grow. If the piles are not stable and they have a tendency to fall in on themselves, you have a smothering effect of the fire. It actually is a greater challenge for the fire to grow. It actually helps in fire control if you have an unstable pile, because everything will eventually fall in on itself and smother things. It's still a challenge to get to the base of the fire, but for the most part, it's not as big a challenge as if you have a stable pile. So the designer is going to need to take a look at that as well, and that's where those wood pallets and the reinforced plastic pallets come into play that need to be considered. And then we've got rack storage. All right, is it being stored on racks? Now, these are not shelves anymore. These are big, deep racks. Okay, it can be up to 36 inches deep, in some cases 4 feet. So the point is that these keep everything in nice order while they burn. Okay, this keeps everything right in place, whether it's burnt, while the fire is going. It doesn't go anywhere, it doesn't fall off, doesn't do anything else. It just burns. Okay? So this becomes rack storage, becomes the biggest challenge. Protecting against rack storage is a bigger challenge even than the pile storage. We can go much higher, 48 feet high in rack storage. Structurally sound, and a lot of air moving around inside. Okay, mainly because we've got air coming in on what we call flue spaces, transverse flue spaces going in, and we've got air behind it moving along the whole length of it in what we call a longitudinal flue space. If we've got two double row racks back to back, we'll show you some pictures of that. Here's a great example of that. Okay, not only do we have air moving around all of this, but we've got air that can move down the flue spaces between the two racks. So there's a lot of capability here, possibilities for that fire to grow. Also, because it's so large and because these are pretty solid units that are there, it's a bigger challenge to get water down through them. So not only are we getting a lot of air, a lot of fire and heat and everything else going up, it's a bigger challenge to get water to come down on, to get water back into these spaces. So when we're looking at rack storage, we have to take a look at, okay, are we protecting up at the ceiling line? Is that sufficient? What type of sprinklers are we going to use at the ceiling line? Or do we have to put sprinklers do we have to figure out a way to get sprinklers all the way down into the rack itself so that the fire doesn't grow so big down here that by the time it gets up through to the top, grows to the top of the rack, it's already going to overpower my sprinkler system at the ceiling. So those are two big questions we're asking when it comes to rack storage. Then of course you get into multiple row racks, back to this same picture. And it doesn't end here, you can have 4 of them. You know, it just doesn't end. We can have 3 here or 4, but here's a classic example of a multiple row rack. Very deep, all right? Probably about 12 or more feet in width, all the way down the aisle. Okay, aisle 19, all the way down, and just loads of material stored everywhere on it. Bigger challenge for our sprinkler system? You bet. Now, to make things even more interesting in the storage industry, we have movable racks. All right? So think about the doctor's office where you go and they've got your records and they crank this, they crank it and the bookshelves or the file shelves move along, right? Or they can push a button and do the same thing. That's movable racks. That's these here. They move as a unit. They move as a single unit, creating and eliminating aisles as they go, just to get access into this. These go along a specific rail system here. Same as those book or those file shelves. All right? How do you protect against this? Same commodity, same arrangement. Looks an awful lot like a regular rack system, except we got 1, 2, 3, 4 of them together now, probably 5 and another one here, and you only open them up when you need to get into a specific commodity area. Can't put rack sprinklers in there, so what are we going to put up at the ceiling line? All right? What's the challenge? We're going to have to come up with some sort of a fix for it. So it's going to require more water. It's going to require a different approach. And then finally, totally portable racks. These right here move along a rack. These right here, you build them as you go. There's a rack, there's a rack, there's a rack. You can see it right here. Fork truck comes along, sets it right on top of each other. Boom. So this whole thing moves. You move the entire rack at any given time. You just replace it, move it around. Okay? No in-rack sprinklers there. Okay? Behaves an awful lot like by the time you put them together, it might even look like more like a solid pile. But again, that's the issue that we are challenged with. Now, another item that will impact the sprinkler system's design for in NFPA 13, another component that impacts that is aisle width. Now, aisle widths have changed dramatically over time. The requirements in NFPA 13 still are based on 4-foot aisles or greater than 4-foot aisles, up to 8-foot aisles. But what happens with those wider aisles? If I'm the building owner, if I'm the owner of a warehouse, and I look at an 8-foot wide aisle, what do I see? Wasted space. Yep, I see wasted. How do I get that closer together?
Stack them on the floor.
Right. How do I limit, get that in there? Well, I can, all right, I can go 4 feet, but what's that gonna, a 4-foot aisle, what's that gonna do? That has an impact on my sprinkler system design. Why? Because if I get a fire going here, and it starts rolling up the outside here, burning this, if I have another aisle only 4 feet away, it's gonna jump the aisle, all right? The heat from this fire here, and we've got some pretty dramatic video that you can see in some of these fire tests. All you got to do is, fire test jump aisle kind of thing on YouTube. You'll see it. Basically, you get the fire here, burning here. It heats the commodity on the other side and eventually jumps the aisle. Okay, the fire on the other side jumps out. That's actually one of the success or failure of a sprinkler system's test when we're designing or testing sprinklers to protect rack storage is, we have what we call the commodity that's being tested, and then right over here we got what we call the test array. All right, and one of the things is you cannot let the test array go on. The exposure catch on fire, or you fail the test. If it jumps the aisle, you're done. Test failed. Okay? All right. So when it comes to flue spaces, we talked a little bit about those before. Longitudinal flue spaces run parallel, run all behind the racks here, okay? And transverse flue spaces run in the direction that you're loading. All right, fork trucks coming in, loading them in here. The transverse flue space goes to the other, just to the other side of the rack. So that's parallel to the way that the commodity is being loaded. And these are important. Flue spaces are important in rack storage for two reasons. Now remember, we said they entrain a lot of air in there, so you can get it gets a fire going. But what it also allows to happen is, if I get a fire going in here, it allows that heat to go up through the structure. Where are my sprinklers? They're at the ceiling, or they may just be at the ceiling, or they may be somewhere in racks here. It allows that heat plume to travel up through. What does it also allow once the sprinkler operates? Water to come back down. Okay, so flue spaces become a critical component not only to the design, where the designer is assuming flue spaces are going to be maintained, but also to the inspection, to the inspector coming around, making sure that flue spaces are being maintained. Because remember also, now not in this particular case, but let's just say I got a couple of smaller loads in here, but I can only put two loads in here because I need to maintain my flue space. But if I push it all the way over, I can get a third box in there. What does that mean for me? More storage stuff. Okay, I can store more stuff. Better money, more money. What has it done though? It's choked off the ability of my sprinkler system to operate. So we need to maintain our flue spaces. Critical. Once again, it's that balancing act with what I want to do as an owner and what the system is going to be capable of doing. Now, within these racks themselves are special definitions too. All right? As we're looking at the rack, is it an open rack? Or does it have solid shelves on it? So it's racks without shelving, or this is an open rack. So we want to make sure as an open rack, we've got we can have the most amount of water coming down through. So in this case here, an open rack is racks without shelving at all, or with shelving in racks that are fixed in place. But again, no more than equal to or less than 20 square feet of the shelving. Might have wire mesh, or with shelves with wire mesh, or a slatted surface. It's got to be more than 50% open. 50% open is the big key here. The idea here is that you have a shelf. You've got to put it on you got to put your commodity on a shelf area, but it's open, and it allows water to flow down through it. Okay. So the big things here are that it's racks without shelving, or it might have some sort of a shelving surface. Less than 20 square feet in the shelf area. It could be wire mesh, and 50% open. Great example of an open rack. Okay. The big challenge with this is you can only put certain things on it, right? You can only put stuff that's on a pallet in this particular area, in this space here. So you don't always see that. What you're more likely to see is some sort of a shelf arrangement, or a flat arrangement here for something to be put on. Wire mesh shelving is a perfect opportunity to do that. It's just not as strong as maybe wooden slats, things like that. So again, it all depends on what's being stored. So the shelf area then, it becomes a critical point of determination here. Is the surface of the shelf in a rack is defined by those perimeter aisles and the flue spaces. So how much area do I have? Because remember, we can only go up to 50% open, or by the placement of loads blocking the openings that would otherwise serve as required flue spaces. So in this case here, what we're looking at is where, right here, we've got a lot of load coming in here. Whoop, went the wrong way. In this case here, we've got a lot of load. Here's where they attempted to leave it as an open rack. Okay? They said, oh, okay, we're going to have open rack storage because we're going to have the wire mesh on there. Well, then they started putting textiles on it. All right? And then, so you can't put textiles on mesh shelving, because what does that do? It
Damages.
yeah, it damages the thing, the material. Okay, you'll get the checkerboard effect in there. It'll look bad. All right, it'll damage the material. So what did they do? They put plywood on it. Perfect. What have they done? They've taken an open rack construction. They've loaded it all the way out to the vertical barrier, the vertical supports, killed all of the whatever flue space was there. There wasn't much there anyway. They ran it right to the back here. Now this is a new set over here. All right. They jammed it all together. What have they done? They just created an entire mass of material that it's overrun the shelf area. No flue spaces at all. Big problem. All right. So we can go to slatted shelf on the rack or a solid shelf on the rack. If we have slatted shelves, we can still be open as long as we got that 50% open material. Material is 50% open. A solid shelf, we can go with that too, but what it means is we're going to wind up with in-rack sprinklers. You're going to wind up having to put sprinklers down in there because solid shelf is going to impede the flow of heat going up and water coming back down. So this is permitted. Here's solid shelves in the racks. That is permitted, but you got sprinklers up in the ceiling here. What I'm not seeing right at the moment is anything down below those solid shelves.
So I just,
Sure.
well, on a company inspection, you only have sprinkler heads at the ceiling level,
Mm-hmm.
and they're high capacity.
Okay, they're ESF,
Right,
they're
right.
storage level
Right.
sprinklers. One of those, one we're going to talk about.
I look and I see that we've got solid shelves.
Mm-hmm.
So it sounds to me like that's a dead giveaway that you've exceeded or violated the design. Okay.
Yeah.
Solid shelves have to have in-rack sprinklers.
Well, solid shelves are a red flag for you to go back and question the design.
There you go.
Okay, they're absolutely a red flag. So basically, what we're doing here is, typically when I have solid shelves, you're going to wind up with in-rack sprinklers in those locations. There may be times when there may be designs that are using those shelves as barriers and intended to be there. But yeah, a solid shelf, you're going to wind up with in-rack sprinklers. If you don't see in-rack sprinklers in a situation like this, that's a red flag. Find out, consult with the designer, what was the design intended to be. All right? So when it comes to sprinkler protection, what type of sprinkler is being used is a critical question. All right, so we know what our commodity is, we know how it's being stored, so we've classified it and we've put it in whatever kind of arrangement it's being stored in. Now we need to pick a sprinkler. All right, we pick a sprinkler based on the designer looks at that and says, all right, in consulting with the owner, maybe with the AHJ, but ultimately it's the designer, the engineer's final decision. What type of sprinkler am I going to use? Am I going to use a control mode sprinkler, a standard spray control mode sprinkler, or maybe a larger orifice control mode sprinkler? Am I going to use what we call a CMSA? Now, CMSA means control mode specific application. CMSA, control mode specific application. ESFR sprinkler. We're going to use an ESFR sprinkler, which is an early suppression fast response sprinkler. Or are we going to use a special design? All right, maybe there's a special type of sprinkler or a special design arrangement that is specifically geared towards protecting this commodity in this arrangement. Or are we going to use, and do we have to use in-rack sprinklers? Okay. Now, it's important to note here, it's really important to note these two items in particular. Control mode. And the reason I want to point this out is because this is where, when it comes to the overall design, the overall approach that NFPA 13 has taken to the protection of commodities and protection of storage arrangements, that this is the one, these two, and then this ESFR are the ones that kind of were game changers. The ESFR was a game changer back in the late 80s, the development of this. For 100 years or so, prior to the development of the ESFR sprinkler, we were designing sprinklers and sprinkler systems that over time, what would happen is you'd get the start of the fire would grow. The sprinkler system would then operate. Okay, so the temperature would go up, the sprinkler system would operate, control the fire until big water showed up. Okay, fire department with their capacity of 250 or more gallons per minute, and then the fire would go down and be extinguished. Okay? In the 80s, and then in the 80s it started, in the 90s it became even more prevalent. We came up with an ESFR sprinkler. All right, the ESFR sprinkler was developed. So we went from this control mode up here to actually being able to suppress the fire, put enough water on that fire to actually, as it took off, it would do this. The ESFR sprinkler would kick on, and you'd go down to this. You wouldn't get final extinguishment necessarily, but it was suppressed to a point where it simply would not pose a further threat, as long as the fire department showed up and put it out. Yeah.
There's a huge amount of complacency amongst firefighters that they assume that if it's sprinkler, that it is designed to extinguish the fire.
Mm-hmm.
And in fact, there are government officials that will use sprinklers as a justification for reducing staffing on fire departments, when what you're telling me here is that that your conventional, traditional, older sprinkler systems are designed, predicated on there being a fire department that's going to be there to finish the job.
Right.
Okay.
So, yeah, it's one of the delicate balancing acts that the sprinkler industry always has to go through with the fire department. Okay? Because, number one, while it is true that it's designed like that,
Yes.
Doesn't mean it's gonna work that way.
but no, what actually winds up happening is we wind up being a victim of our own success. You wind up showing up and there's nothing left to do.
That's right.
That is absolutely, so while the system is designed like this,
Yeah.
what actually a lot of times happens is, boom.
Yeah. Oh yeah. Most definitely.
Okay.
No
So-
question about it.
But that is the delicate line that the sprinkler industry and advocates for it walk when we have the fire, with the fire department. Because there's truly, clearly that kind of discussion that goes on. You haven't identified, what you've identified as one of those really interesting ways of trying to put two groups together, both involved with fire safety, and advocates for it that are coming at it from a slightly different view. Although we want that fire to go out. So, but that's true. This is control mode, and when it comes to these sprinklers, it's based on what it's designed to do. So the control mode sprinkler, the CMSA sprinkler, is intended to control it. Most of the time it also extinguishes it.
Yes.
Whereas the ESFR is intended to, it's designed to put so much water on a fire, boom, that it suppresses it. Now, what's important here is that the ESFR and the CMSA sprinkler are primarily geared towards storage protection. Okay? Now, they can be used otherwise, but I don't want 100 gallons a minute coming out of a sprinkler in this room. I certainly wouldn't need it. All right? It's over-designed. It's intended to protect high challenge fires that normally occur in storage occupancies. That's what we've tested these for. That's what they're geared for. Okay? All right. Okay. Now, chapter 12, now we get into the specifics, some specifics. Now, we're not going to get into all of these again. That's a 2.5-day program. But chapter 12 is the general chapter that covers all storage occupancies. You have to comply with chapter 12 when you're protecting storage occupancies. That's your first stop. All of these in here. Whether it's the hose connections, adjacent hazards, wet pipe systems, dry pipe systems, pre-action, all of this here is you visit chapter 12 first. Okay? Then, based on what you've determined before, you get into your subsequent chapters, which we'll talk about here. Okay? And chapter 12 has a couple of things to say here about what goes on at the ceiling line. In other words, when it gets into these, we don't like vents. We don't like roof vents in NFPA 13 and when it comes to storage protection. All right? Why? What do roof vents do? They vent. Yeah, they vent the hot air. And what do we need? We need the hot air to activate our sprinklers. So if vents are operating and taking away that air, that hot air, we have a tendency to have sprinklers perhaps go off where we didn't intend them to. It creates a situation called skipping. On the other hand, if we have vents that are rated to go off at temperatures greater than what our sprinkler system is going off, that's fine. Okay? All right? Hopefully they never work, but they may also be automatically turned on once we've.
So if you got a vent over here and the fire's here, it'd be like a fireman cutting a hole in the roof in the wrong place.
In the wrong place. Yeah. It could be that you have sprinklers going off where there is no fire.
Got it.
All right? Now the same thing goes for draft curtains as well. Draft curtains separating two design areas is fine. Draft curtains within certain areas, especially where ESFR sprinklers are concerned, have a tendency also, remember, those are a lot of water, a fast response. So what we need to make sure here is that we get the heat into those areas. We don't interrupt the heat flow around the ceiling, because once again, if we have draft curtains, it could cause skipping of the sprinkler operation. Building and storage height is also an issue. Now this is an interesting issue that kind of works in the reverse way that you would think. But what we found is that this relationship between the storage height, now storage height is one thing. The higher you go, the more storage you have. But what we also found was there is a relationship between the amount of space you have between the top of the storage and where the ceiling sprinklers are, how far above that the ceiling sprinklers are. So let's take a look at this for a second here. And what we've got here is, let's just say what we have is 15 feet of storage. Okay, we got 15 feet of storage. There's my fuel load right there. And I've got 25 feet above that to my sprinkler. Okay? What we found was that just because we have a smaller fuel package, a lower fuel package down here, that still can create a fairly big challenge for my sprinkler system up above. And here's why. I get a fire that starts down here, and it comes up through, and its heat plume starts to grow, okay? And with it is velocity, all right? That heat plume starts to grow, and there's a lot of velocity going up. And the further up it goes, I've got my sprinkler up here now. Oh, this is cool, I can use that roof line, all right? I've got my sprinkler up here, and the more velocity that's created, the greater this plume becomes, the more difficult it is for the water droplets to penetrate down through the plume. Okay? This becomes the biggest challenge. All right, or not the biggest challenge, this becomes a big challenge. And it's not what you expect. You'd say, well, less material, easier fire to put out. Not necessarily. So what we have in NFPA 13 is a limit to the open space above storage. So even though the owner is saying, I've only got 20 feet of storage, the designer is going to be required to design as though there is this phantom storage up here up to 20 feet. To get 20 feet. So right here I would have to go to what? 25, right? 25 feet? 25 feet here. So I would need to go to, so I would have to go up to 20 feet of storage. I would have to actually design this as though there were 20 feet of storage. Now that means something when we get into each of the chapters, okay? Because remember, storage, the design of your storage sprinkler system is based on, one of the things it's based on is that storage height. So even though there's only 15 feet of storage, I have to treat it like it's 20 feet of storage in this case. If I had a 30-foot separation here, I'd need to treat that, what? As though it were 35 feet of storage? So, again, one of the interesting components here. All right, now we talked about this the other day. High volume, low speed fans. Big deals often used in storage warehouses, things like that, to keep the air moving. The question then becomes, does it impact the operation of the sprinkler system? The answer is, in a research project that was done, is not so much. As long as basically this item here it stops before it shuts down with the alarm. The detection system shuts the fan down. And you have, as far as ESFRs are concerned, spaced equally around that particular unit. We can treat this simply by standard obstruction rules at that particular point. Also, the adjacent design. Remember, we said that you may have a situation here where we've got lower hazards next to higher hazards. What do I have here? I've got pallets stored inside. A big challenge, first of all. But we've also got some material at a much lower level under this mezzanine, and we've got big high rack storage over here. So those are two different design criteria you can use. All right, you don't need quite as much water there as you do over here, but the standard allows you to and requires you to actually design this separately, but separate this space here by either changing the roof height or by having draft curtains up above, so that we don't have a fire in this case here operating sprinklers out in this design area, or vice versa. All right, so we've got a requirement for a separation here, an aisle separation, and a draft curtain, or a separation in the ceiling height. And then we can have these two design areas close to each other. And that's the only time you can use draft curtains. You couldn't use draft curtains if this is an ESFR sprinkler system out here, which most likely is. You can't have draft curtains out within this design area. but you could have a draft curtain separating the two design areas. Protection of idle pallets. Again, idle pallet, that's a big fire hazard right there, and plastic ones in particular. Okay, best way to protect idle pallets is outside the building. Right, get them outside. That's the best way to provide that protection. I will tell you though that you are going to, the NFPA 13, if you wind up with idle pallets being stored inside, either attached to the racks or inside a building, here's some plastic pallets over there, or some wood pallets there, that Chapter 12 does have specific guidance on protecting inside. And the best thing that they say about protecting inside, as I said before, is get them outside. All right, don't store them inside. All right, so after Chapter 12, you come to Chapter 13, which deals with what we call miscellaneous or low pile storage. So in NFPA 13, what you have is you have the occupancy hazard classifications: ordinary hazard and light hazard, ordinary hazard group 1, ordinary hazard group 2. They all stop in their storage height at 12 feet. Okay, so at 12 feet, that's kind of the end of occupancy class. If you have storage above that, you have to go to the storage occupancies. However, you do have certain warehouses that are storage. That's what they do, but they don't store above 12 feet. So what it becomes is what over the past editions was called miscellaneous storage, and it was kind of limited to this one particular area, and we'll talk a little bit about that in a moment. But now it's also got low piled storage. So this is a warehouse. It's a warehouse. It's a warehouse. It's not anything else. It's not anything that actually can be defined in as an occupancy hazard classification per se, but it is a storage application. But it's low pile. So what do we do with it? What we're going to find is miscellaneous and low pile storage. First of all, it doesn't exceed 12 feet in height. Because once it does, then we're off into the storage requirements. We're off into 14 through Chapter 14, 15, 16, or 17. It's incidental to the other occupancy. In other words, it's kind of, it's being used a lot. There's a lot of traffic in this. It does not constitute more than 4,000 square feet in the building. Individual piles are no greater than 1,000 square feet. Okay, so this is 4,000 or 10% of the building, whichever is greater. And each pile area must be separated from the others by at least 25 feet. So low piled storage is simply anything that's solid pile palletized, rack storage, bin box, shelf storage, anything that's up to 12 feet in height. All right, so we've got this miscellaneous storage that has this use that is being, that's being associated with it, that it's basically incidental to the other operation. Then we've got low piled. This definition is not intended to address the design approaches or the protection schemes, but instead, this low piled storage is to say anything below 12 feet. If it's below 12 feet but you're in a warehouse, you treat it like low piled storage. Now the miscellaneous definition looks like this. Okay, remember we said piles 4,000 square feet separated by 25. No more than 4,000 to the whole space of 10,000. So that's miscellaneous and low. That's miscellaneous storage. The low pile storage is something quite different. Okay, in that it could take up all of this space as long as it's under 12 feet. Now the real issue here then is, what do we do with this? Well, Chapter 13, interestingly enough, Chapter 13, if you're in miscellaneous storage or if you're considered low pile storage, you're going to go back and protect it like one of the occupancy hazards, whether it's ordinary hazard group 2 or ordinary hazard group 1. All depends on what you're storing here. Okay. So the Chapter 13 is a pretty short chapter. It says, okay, you got low or miscellaneous storage. Go back to the Chapter 11 for your design parameters. All right. Then when we get into all of the rest of this, Chapter 14 deals with class 1 through 4 commodities. And this is why it's important to get your commodities straight. All right? Understand where your commodities are, because class 1 through 4 commodities, if they are palletized, solid pile, bin box shelf, or back-to-back storage, it goes into chapter 14. So I've identified my commodity, I've identified how it's being stored, I go to chapter 12, and I go to chapter 14. All right? 12 and 14 for these, for these particular items. Within 12 and 14, what type of sprinkler are we planning to use? All right, CMSA, ESFR, control mode, or maybe even high expansion foam. Well, in control mode, that's going to change if I go up to 12 feet or over 12 feet, or encapsulated over 15 feet but up to only 20 feet. I can use control mode. So that, remember, if it's encapsulated now, I can go up to 20 feet with control mode sprinklers. If I go over 20 feet with that, what am I left with? CMSA, ESFRs. Okay, I don't have to get rid of the whole thing, but that's what I'm limited to. Chapter 15 then is plastics, but not just any plastics, right? Because the only plastics we have left are Group A plastics. So it's Group A plastic. Again, palletized, solid pile, bin back shelf storage, back-to-back shelf. And in this case, if I'm using control mode sprinklers, this is where all these terms then begin to come back around. And this is a decision tree in chapter 15 that says, all right, I'm plastics. All right, I have plastic being stored. What kind of plastic? All right, we know that if it's Group B or Group C, we're going there. But all right, so now I've got Group A. I got Group A plastic. What's the next decision? Is it expanded, unexpanded, or free-flowing? Okay, we covered those definitions. All right, it's expanded in this case. Okay? Is it cartoned or is it exposed? Is it in a box or is it not, this expanded plastic? Okay, it's cartoned. Is the pile stable or is it unstable? Okay, it's stable. The design criteria, therefore, for this particular control mode protection of Group A plastics in a pile storage is then found in table 15.2.6, A or B, depending on your approach. Okay? That's the decision tree. But remember, it pulls together all of those things we were just talking about for the last hour and a half. It pulls in all of those things. This is why you need to know each of those definitions, each of those terms, and each of those arrangements. Control mode, CMSA, ESFR, high expansion. Now, we'll stop here for a second, because I want you to go to these. Especially as we get into commodities stored in racks. Chapters 16 and 17 deal with commodities stored on racks. And again, we have general requirements and then requirements out for protection of steel columns because protection of movable racks. Steel columns become a big issue here with rack storage because we have steel columns, unprotected steel columns, running up through our racks sometimes that are holding up the building. So there may be situations where we have to design sprinklers to be spraying onto the steel columns within our racks in order to provide the protection and the strength. High expansion foam becomes an issue for class 1 through 4 only. Solid shelves need to be considered in the general requirements. In-rack sprinklers, horizontal barriers, not necessarily shelves, solid shelves, but actual horizontal barriers may be designed into open racks to control fire in specific areas, especially as we get into very tall racks. And then flue spaces need to be maintained. So for rack storage, the thresholds are for both plastics and class 1 through 4 commodities, we take a look at that storage height. Because the requirements are going to change once I get over 25 feet in height. Chapter 16 then, control mode can be used, control mode sprinklers can be used up to 12 feet or over 12 feet. We've got specific guidance given, and we break it out again from 12 to 25, up to 25 feet or over 25 feet. There's specific requirements for each of those, just if we're using standard control mode sprinklers. CMSA sprinklers, ESFR sprinklers are then are also called out. So if we go to page 4 in the quick reference guide, you can see control mode density area sprinklers, CMDA. They're just control mode sprinklers. These are the types of sprinklers that we would be using in that control mode, perhaps, arrangement. And then in-rack sprinklers here, both 16 and 17. In-rack sprinklers we have on on page 5 out in the back. We see examples of our in-rack sprinklers that are down to as low as K5.6 or K8. Basically, these are smaller orifice sprinklers intended to be installed in the rack structure itself at certain specific locations as identified by Chapter 17 or Chapter 16 or 17. And they are used to help get that water down in, react sooner to a fire and get that water down into the burning commodity faster than the reaction time of a ceiling sprinkler or a sprinkler at the ceiling. But once again, when you get into Chapter 17, you once again have a decision tree to go through. Group A, carton protected using Chapter 17, exposed. Down here, then we get into a decision tree of down to non-expanded or expanded plastics. This is what we see when we're looking at in-rack sprinklers. They can truly be, most of the time what you have is sprinklers that are out either at the face of the rack or they're back in the flue spaces. Rarely do you see one, you don't often see one that's out really above the load right here, because that can get kind of dangerous as far as getting damaged. But in this case here, they're using one here, they're putting one there as well. But normally you see one here, you can see one here in the face of the face sprinklers, or you can have them installed basically in those flue spaces, is where you're going to, in the intersections or portions of the intersections of the longitudinal and the transverse flue spaces. Now, I'm going to finish out our storage session here with just kind of a rundown some of the special types of storage that you can run into that have specific requirements associated with them. Rubber tires, any type of protection used for rubber tires is going to be detailed in Chapter 18. Rubber tires burn really well. They're a big challenge. Anybody that's gone to a rubber tire piled fire, I'm sure, knows this. Okay, so they are a big challenge, and especially if you put them up on racks. Now you've got a lot of air going around. You get a fire started here. It's a big challenge. Chapter 18. Chapter 19 addresses rolled paper storage. Now this is kind of this is kind of a holdover from this chapter in and of itself has not changed much at all over time. But this is basically if you're protecting a rolled paper storage warehouse area, you don't use Chapter 16, 15, 14, whatever it is. You go right here to Chapter 19. Chapter 20 deals with special designs. Now, you can have special commodities that you're not really sure what commodity classification they are. Maybe you have to do some fire tests, or you try to get a specific heat release rate. But in Chapter 20, we deal with special designs of storage. And in this case here, we have a very tall, this is like a 50-foot high compact record storage facility. This is a federal government facility, but it is basically, again, like those compact shelf storage that move in the doctor's office, okay, or the lawyer's office. These are the same thing. It's archives. All right, it's archive storage. So there's a special design. In FPA 13, nowhere else in the document can you find this particular arrangement. You have to go to Chapter 20 for the specific design. All right, of these, and it is typically these are protected by the design criteria is ESFR sprinklers. ESFR sprinklers protect this commodity at 40 psi, I think it is. Anyway, and the other interesting component here is that the support structure for this unit is required to be hollow tubes. If I get a fire going down here, this is pretty lightweight steel, all right? You get a fire going in here, you can easily collapse this thing by weakening the steel. So how do they protect against that? You have hollow tubes that run down, and what goes down the hollow tubes when the sprinkler operates? The water does. So they've tested this out. This is not something that they came and, they actually came to the sprinkler committee in the 2010 edition with this proposal, having tested it all out. Another one with compact record storage is multiple levels. All right, in here we actually have catwalks to access all of this archival storage. When this is built out, it will be solid record storage from bottom to top. Okay, and we have a catwalk that goes down the middle to access it all. So we have to put sprinklers. Pardon me?
That looks like an automated system.
No, this is not. This has not gone to automated. This is manual. This is man. That's a catwalk right there that people.
Down below, see the yellow in the bottom there? That looks like.
No, that's another catwalk. There's another catwalk down here that it's operating on. We haven't gotten to the automated one. That's a totally different animal. Okay, so other issues then when you get into specific commodity in chapter 20s when we're looking at specific commodities, plastic motor vehicle parts, they get stored kind of differently than everything else because they need quick access. Automated storage, very different. We don't even have anything right at the moment in automated storage. That is truly an engineered system that is being put in there now. And displays in retail stores are also another one. Finally, carton record storage. When we get to carton record storage, this is the typical arrangement you might see in racks. But then we go to the one where we've got I showed you before that had the access through the catwalk that goes down into that space. So we need to provide that protection here. This is what we were looking at before with the catwalk, is that we have cartons all the way between the two rack members. We have access being provided here, here, here. These are catwalk accesses to these spaces here. So we're going to have a sprinkler in the rack and alternatively underneath the catwalk. So it's a special design for that particular arrangement in chapter 20. All right? We look at the structural arrangement and the sprinkler criteria, whether it's for the ceiling sprinklers, the intermediate level, or in-rack sprinklers. And here's another look at the catwalk. Here's another look at kind of how it is arranged. Okay, and finally, we'll finish with this one, compact storage. Now, this was an interesting one mainly because with compact storage, what they were trying to do was not call it storage at all. All right, they were saying, look, these go up to a certain height, but they're always in a light hazard occupancy. They're always in a doctor's office or a lawyer's office or something like that. So the question was, can we protect these, the storage that's in here, with simply a light hazard occupancy approach? And so, sure enough, we looked at this and said, well, man, there's a lot of fuel in there. That's going to burn really well. No, a lot of times it's so compact together, and because there's no flue spaces in here, what they found was, yeah, actually, if you limit the amount of plastics that can be used in here, if you limit it to files only, that basically, yeah, you can protect this kind of a space as long as the limit is the height is 8 feet, commodity, clearance is 18 inches to the sprinklers. You can use standard spray sprinklers. The module, you govern how the structure is constructed and its footprint. All right, and those are all detailed in section 20.6. All right, that's compact storage module. We talked about high bay construction there. That's the description. finally, and again, I promise this is finally, we've got 2 things left here. 6-sided portable storage containers, pods. How do we protect these? Don't know, okay? We really don't. When I asked this technical committee on this before, back in 7 years ago, I asked the technical committee this question, and they said, well, we just use ESFR sprinklers. We just spray the whole thing. All right, right down over the whole thing. However, there are a couple of footnotes that we can use. But basically, so they came up with a definition of what these things are: 6-sided storage. Okay, and then they said, here, the technical committee on sprinkler system discharge is unaware of any fire test and no design guidance is furnished. Okay, you're on your own. However, you're kind of not on your own, because remember, you go back to this decision tree. All right, you go back to this decision tree, which takes you down through, well, what's the worst thing you could possibly store in there legally? Okay, legally, what's the worst thing you could put in there? Is a Group A plastic, right? Because you can't put gasoline or anything like that else in there. So it's a Group A plastic. Well, there's 2 footnotes down here below this decision tree that say, look, Group A plastics are permitted to be treated as Class 4 commodities under the following conditions. The multiple layer corrugation is equivalent to the outer material, or equivalent outer material will significantly delay a fire. Okay, and the amount and the arrangement of the Group A plastic within an ordinary carton would not be expected to significantly increase the hazard. So as long as I'm not putting gasoline or anything in there, one of the approaches that you can take is protect it like a Class 4 commodity, because this thing kind of looks better than a cardboard carton, doesn't it? Like it would resist fire in a cardboard carton a little bit better. We're not talking about dropping protection down into it. We're just talking about protecting the warehouse that it's sitting in. So it's possible. I tell you that mainly because when I asked the question, some people said, no, you can do it as a Class 4 commodity, and others said, no, we just do ESFR Group A plastics and we're done with it. Okay, here's something you see down here, huh? Maybe, for a while anyway, you'll see them. It's like, how do we protect them? Here's one with a sprinkler system in it. Okay, this is a big challenge. But once again, the technical committee has punted on this one. We have absolutely no idea what to do with boat storage. And here's the reason why. We can tell you that it's plastic. Okay, great. We know how plastic burns. We know how the foam plastic burns with the seating inside of it. We know that there's fuel in there, so that's going to be a problem. We know that it's in racks. The big challenge with putting sprinklers up here is, and I get a fire in my boat here, what happens? All that water comes out of the ceiling, and where does it go?
In the boat.
Yeah, it goes in the boat. It goes in this boat in particular, and that boat there, and it gets all collected. It's a highly shielded fire also. And then, okay, so let's fill a couple of boats up with water on these racks. Now what happens?
It collapses.
The whole thing collapses, okay? So once again, you're on your own when it comes to these. So I told you all that sophisticated stuff we go through with everything else, and we still have things we're learning. We still have things. Now, I'm a boater too, and so I don't want to see any research on this stuff because I hate seeing boats burn. You know, even junky boats. It's just like, I don't like that at all. But anyway, so it's a highly engineered design. All right, there is no guidance in NFPA 13 on that. With that, thank you very much for your time.
Thank you.